Now, so far you might ask, Frank, what is that package good for? I just Google computation of power indices, and I click my way through to Dennis Leach's website, and there you can just click here, and up there you calculate, for example, the Shepherd-Shubik index for the electoral college. And that's actually true. It's a really nice tool, and I think it's extremely helpful. And it's something that I always would favor against installation of another tool. But sometimes, there are good reasons for actually using this package here. I think there are four good reasons for using this package here. Reason number one is if you want to do bigger calculations, as for example, around the EU Council. I'm not sure how far you get with these websites. Number two, if you want to repeat, and I think this is the most important thing, if you want to repeat a computation, for example, when you want to run some simulations, then you just need to be able to script things, and here it's just very, very comfortable with Python. Number three, if you're interested in what's going on actually behind the scene, very easy to do. You just click into this file here and you read the code, and it's really easy to read. In combination with Sasha Court's paper on computation of power indices, you will easily understand what this code actually does, and you can modify it for your purposes. For example, you might want to use just-in-time compilation from the package number to make it faster. And well, of course, there's another reason, namely that Andre Casares and we have just introduced the Coleman-Shapley index. And as far as I know, there is no other tool out there that can compute it. So you're then kind of forced to use this package. And yeah, these are the four reasons that I think justify usage of this package. All right, now let me demonstrate to you how to actually calculate the power distribution in the European Council. How are the rules? Well, there are 28 countries represented by these leaders. And in order to pass a proposal in the EU Council, you have to meet two criteria. Number one, 55% of the countries have to agree. So at the moment, that means 16 countries have to agree to a proposal. And the second criterion, the countries that agree have to represent 65% of the population. If you want to have this a little bit more concrete, you just go into the example pi file, and there you can find that one more time. And let me just copy this code here to Spider, and this time I'm looking here on the left-hand side where I can write the script, and I'm not really using the console anymore because that's kind of cumbersome. Let me just restart the kernel. So you see, I've done this before, it works. And we start again with importing the package Powerindices. Let me just uncomment everything, and oh yeah, that's very important. I also have to remove these spaces, because Python is very sensitive to spaces, at least in the beginning of a line. Now, well, let's just run this, and meanwhile, I tell you what it's doing. So here we define a list that contains information about the populations in all these countries. And then we take this list and make a list of weights out of it. This is called list comprehension. All right, I'm not assuming that you are fluent in Python, so let me write this a bit more explicit. What it's doing is actually saying the following. Alternatively, I could also write weights as an empty list, and now for I in E28 pop, please do the following. Take this I divided by 10,000. So take, for example, this number divided by 10,000, then round it and make it an integer. You might say, well, if it's rounded, then isn't it an integer already? Yes, it is, but internally it's still saved as a float, and with this int command, it's then actually becoming an integer. So I could do the same, could basically say, let's take this entry and convert it to an integer, where I basically ignore these numbers. Why do I do this? Essentially for speed reasons and for another reason. Well, these numbers, they're not true anyhow, I mean, they're either outdated or they're estimates, but definitely overly precise. Maybe you would prefer to just round it by 1,000. Okay, so I was talking about this line. So I first take these numbers and divide them by 10,000 and round them. And then I kind of append them to the weights vector. So instead of running this command, I could also run these 3 lines, but well, this is just more elegant, especially if you're into Python. So this will be equivalent to that. All right. So here I've defined the weights, and here I define the quota. Basically, the same thing. I take the population, I sum it up, multiply it by 65%, and then I divide it again by 10,000 and round it back in an integer. When I've done this, I'm ready to calculate the Powerindices. What's the idea here? Well, these populations are the weights. The quota is the roughly two-thirds of the EU population needs to be passed. So each country comes with a weight according to its population, and setting the minimum winning coalition to size 16. I implement this second threshold that, well, 55% of the countries have to be represented. And as you've seen, calculated fairly quickly all these things. I think I also could have done this with 1,000, or even, you can even do it with the real numbers, and then I would say it takes about a day or an hour, depending on, I think limiting factor should be your memory. Now that was easy, and you might say, what did you actually mean with the simulation? And I would like to show you this now. The next few minutes are inspired by a work from a Hungarian scholar whose name I hope is correctly pronounced, Laszlo Kocsi. And he has this nice paper where he looks into the change of the power distribution in the European Union due to a demographic change. And I would like to, do something along these lines now. How do I do this? Well, I need numbers on the demographic change in the EU. And I can go to Wikipedia. I was actually thinking, hey, let's take this table. But as always, there's a catch with non-scientific work. In this case, it's Croatia is missing. But if we click our way through to the Eurostat website, which you should use anyway, you'll find the data there, and then you just download it. And once it's downloaded, you can open it in Excel. How far are we with the download? Okay, there you go. Up, that is the videos. Okay, here we go. Let's enable editing. So here we have the projections, and I'm just demonstrating this here. So there are several scenarios. I'm just taking the first one. And I think it's helpful to actually take these And you know what? I leave out the UK because it's not going to be a member in the future anyway. And let me just transpose this table. And yeah, actually I would like to have these as vectors so that I can put them into the Spider script and the Python script and Spider. And for that purpose, I need commata in between. This can, for example, be achieved by saving the whole thing as a CSV. And well, and I'm just taking this, and yeah, I need to clean it up a little bit. Oof, what is this? Please. It's already complicated enough. All right, so we have to get rid of these dots. And these semicolons have to become colons. Okay, let's first make these semicolons, replace all, and then let's get rid of the dots. And sweet, this, oh, that was wrong. Now we can take this and place it here. Let's call this the EU countries. I know it's not correct, England is still in, but it's just for demonstrative purposes. All right, now I need to store this in a matrix. Let's call that matrix popmats. And actually a matrix is a list of lists. That's certainly not the most efficient way of doing it. Maybe it is actually the most efficient way, but not the most elegant. Nonetheless, I don't want to use more Python commands because I don't want to distract from from what I'm doing by imposing too much knowledge on you in terms of Python syntax and Python programming skills. Let me just run this, and yeah, that worked. So we see the populations and the future there. And now we just go, line by line, and we're gonna do the following. We just take one line, we're gonna compute, well, let's say we compute the CSI and save it. That's it. So how do we do this? Well, we say for row in popmat, and here's really, this is just so intuitive. For row in popmat, we do these things that we've done here before. So we then take this row, and each entry in the row is going to be taken by 10,000, rounded, converted into integer, and we have defined the weights. Then we define the quota, and let's compute the CSI. Okay. And I think we kicked out England. No, England kicked out itself. Therefore, the minimal winning collision size is now 15 because it suffices to have 15 approving countries out of 27 is more than 55%. Okay, and we not just want to compute this, but we also want to store it. So let me make an empty array, and we append this to this array. I hope you kind of understand what's going on here. We're gonna take one of those and calculate the CSI, and we obtain, from this function, we obtain a list of CSIs, and this list of CSIs is then appended to this array. Now let's run this. And here we are. That's it. Well, that's it if you're willing to continue here in Python, but I figured that some of you might actually prefer to have this data somewhere else. So let me add a few more lines, and in those lines we will print out this information into a TXT file from where you can take it to wherever you need it, for example, to Excel. Well, we don't have to invent everything from scratch. The basics are already here in this example.py file. Let me copy maybe this. And all right, what do we do here? We open a file, I call it CSI for now, .txt, and we append to this file. So if the file doesn't exist, we're gonna create it, and if the file already exists, we add to this. And within the next few lines, this file will be referred to as f. Okay, now what's the idea in the next few lines? We're gonna pass through this matrix and print everything into this file. So we pass through the rows from, yeah. And then we pick a free entry in that row. And now we write into the file. Here we have to be a bit careful because this command can only deal with a string. And the entry so far is just a float, so we have to convert it into a string. If I do it like this, it will just put all those numbers after each other. So I will add to this string another string. If I take a string plus another string, it's just, you know, it just makes a longer string containing these two. So I add some space afterwards and a delimiter. And finally, if we at the end of the row, we probably also want to have a line break, and this can nope, it can be achieved by a backslash and an n. So string backslash n. And if I run these few more lines, it's going to create a txt and will print the information that is in the CSIS matrix into this csi.txt. Oh, maybe you were a bit surprised. You can actually run just snippets of the code by selecting them and then run selection or current line. And well, I usually just press F9, so maybe you were a bit surprised when I just run code by, you know, clicking on this keyboard here. That was always F9 that I clicked. And if we just have a look into our working directory, we see the data there. And from here you can do whatever you want to do with it. All right, I hope you've enjoyed this tutorial and you see how to make use of this. I hope you will find it helpful and useful for your own work. If you have any questions, feel free to ask me. Indeed, I also want to improve the usability of this tool, so I think you will also help future users of this tool when you ask your questions to me. With that, I wish you a splendid day. Bye-bye.